Well, good morning, friends. Hope you're all doing fine. So, today I'm gonna tell you about the reaction that takes place between the phenols and the electrophiles. So we don't have a single electrophile; we have so many electrophiles. So, irrespective of the nature of the electrophile, the phenolic compounds, especially the representative phenol, is such which does not require the formation of the electrophile. So we don't require the formation of electrophile. We require only the source of the electrophile. So that source of electrophile is required, and the generator of the electrophile is not. Because phenols are phenols are themselves the compounds which are strongly influenced by the OH group, and the benzene ring is completely charged with the electrons by virtue of the resonance. Hence, the electrophiles are sought by the phenol itself without having the intermediation or intervention of a kind of a compound which is gonna seek or derive the electrophile from the source. So we discussed two reactions today in the class. One reaction is the bromination of the phenol. You see, the bromination is done by using the bromine with the phenol, and this reaction has two variants. One, you can use a non-polar solvent, say for example we have carbon disulfide, and we can use in another reaction, we can use the water as a solvent, that is a polar solvent. So we see that when we use the carbon disulfide as a non-polar solvent, two isomers are formed. So orthobromophenol and parabromophenol are formed. This speaks that here in this reaction we didn't use any kind of the seeker or the agent that that develops or extracts the electrophile from the source. So phenol does it on its own because phenol is highly charged with electrons by virtue of the OH group. Okay. So ortho and para isomers are formed. Whereas on the other side of it, if we use the water, the aqueous medium or the polar solvent, so we see that the reaction does not remain confined to only ortho and the para positions of this type. So we see the bromination takes place thoroughly, and two ortho positions and one para position available in the molecule, they are all occupied by the electrophile. With the result, we get 2,4,6 tribromophenol, which is coming out as a white precipitate, being insoluble there, comes out as a white precipitate. So the reaction has spoken about the fact that when we use water as a solvent, so the course of reaction is different. The justification behind this particular phenomenon is that while we use the water as a solvent, so there is the ionization of the phenol. So phenol undergoes ionization into phenoxide ion and the H positive ion. So thereby causing a greater charge density on the oxygen. So oxygen is now negatively charged, so the density of the negative charge is more. That simply reinforces the electron flow from the O towards the benzene ring, and the activation of the benzene ring takes place so much so that electrophiles are they are overwhelmingly taken at ortho and the para positions. With the result, the 2,4,6 tribromophenol is formed. So this reaction assumes importance so far the board exams are concerned, because we have the board exams coming up for you in the near term. So focus on this example and practice at your home, so that you are able to do it very comfortably in the examination, and you secure the best of the marks that you are aiming at. So thank you very much, and watch me in the next videos for more information about the phenols. Thank you. Have a nice day.